everyone, good morning. Welcome to the channel for Human K. Today, we're going to learn more about the interesting world of configurational theory. It's a method that shifts our focus from just figuring out the net effects of causal factors to figuring out how all the different factors come together to make a certain impact. The main ideas behind configurational theory are conjunctural causation, equifinality, and causal imbalance. Let's talk more about each of these rules and give examples to show how important they are. Conjunctural causation is the theory that a specific outcome is more likely to be the result of a combination of several causes than of a single cause alone. In other words, it shows how important it is to look at how causes interact and work together to produce a result. For instance, let's look at the growth of a new business. Instead of blaming the success of a startup on a single factor, like the quality of the product or the team's skills, configurational theory says that the success is due to a specific mix of factors, like a good product, good marketing strategies, and a supportive network. The conjunctural causation principle shows how important it is to look at how these factors work together and help each other to get the desired result. Equifinality means that different ways of putting together the causes can still lead to the same result. In other words, more than one path or set of circumstances can have the same impact, demonstrating that there is no single cause and effect relationship. For example, let's think about how well kids do in school. Some students may do well in school if they have supportive parents, take part in activities outside of school, and are very driven. On the other hand, some students may have similar academic success because of a different mix of factors, such as having access to good educational tools, getting help from teachers, and having strong problem-solving skills. Even though the causes are different, both groups of kids get the same result: they do well in school. Equifinality is the idea that different ways of setting up conditions can lead to the same result. The idea of causal asymmetry is that the effect of a cause can change based on how it interacts with other causes. It takes into account that the link between causes and effects is not always the same or symmetrical. For example, you could think about how using social media affects your mental health. The causal asymmetry principle says that social media can have different effects on mental health based on other things. Some people may have problems with their mental health if they use social media a lot, feel socially isolated, and have low self-esteem. But for people with strong social support networks and high self-esteem, using social media may not have much an effect on their mental health or may even be good for them. A cause and effect imbalance shows that the effect of a cause depends on whether or not other causes are also present. By understanding and using the three principles of configurational theory, researchers can gain a more nuanced understanding of complex phenomena. We think that the result of interest is closely linked to the ways in which causally important conditions are set up or put together. This idea fits with the idea of causal complexity, which says that a single cause can have different effects based on how it interacts with other causes. To fully understand how powerful configurational theory is, we need to understand 6 basic ideas. The first rule is sets rather than variables. In configurational theory, we shift our attention from variables that can take on a wide range of values to sets that have criteria for membership and effects on classification. For instance, instead of thinking of gender as a variable, we can think of it as a set of words that refer to a group of people, like male or female. The second rule is calibration rather than measurement. Configurational theorizing is different from standard statistical methods because it doesn't use measured factors. Instead, it uses external standards to assign set membership scores to observations. We can compare observations to a set of standards by using this process of calibration. For example, we can figure out if a country is rich by comparing its gross national product to certain limits. The third rule is qualitative outcomes instead of dependent variables. While traditional statistical analysis focuses on figuring out why dependent variables change, configurational theory looks at changes or breaks that can be seen. The fourth rule is constructed populations rather than given populations. Instead of only using given populations or random samples, configurational theorizing includes making populations based on both positive and negative cases of the outcome of interest. By comparing when the result happens and when it doesn't, we can learn more about the conditions that lead to certain outcomes. The fifth rule is set relations rather than correlations. Instead of focusing on correlations, which are the center of most statistical analyses, configurational theorizing focuses on asymmetric set relations. It means that saying that one set is there doesn't necessarily mean that another set isn't. Instead of bivariate correlations, we use truth tables to look at different combinations of causally important variables. Last, the sixth concept is causal recipes rather than net effects. Instead of looking at the net effect of each cause, configurational theory looks at how different conditions come together to cause the result of interest. We want to come up with recipes or sets of causes that lead to the desired result and then test them to see how well they fit with theory and how well they explain the data. Now, let's look at how configurational ideas have changed over time. In recent years, they have added set-theoretic multi-method study, which helps find the best cases for within-case process tracing. We can learn about how general the root causes are by comparing cases that are typical, unusual, or not important on their own. We can use methods like necessary condition analysis, NCA, to look at data. NCA uses the logic of necessity and can be used with either linear algebra or Boolean algebra. We also have methods, like trajectory-based configurational analysis, for studying how things change over time. Also, panel data and time series can be used as diagnostic tools to look at the consistency and breadth of set theory over time. Even though configurational theory came from political science and sociology, it has been used in many other areas, such as business and management, international relations, sustainability, marketing, education, and information systems. Researchers have changed the configurational method to fit the needs of these different fields. Last, let's talk about some worries that have been expressed about configurational theory. Critics say it might be sensitive to changes in consistency, frequency, and limits for calibration. Some people say that we should go back to the cases or look at the data again to make sure that our conclusions are solid. We must also be careful about endogeneity, taking into account missing causal factors and the possibility of drawing wrong conclusions. Even though it's gotten easier to find good cases for within-case process tracking, it's still hard to get the most out of temporal theorizing and time series configurational analysis. Some critics also question how configurational theory fits with complexity theory, pointing out that the three core ideas of systems theory and complexity theory are different. In conclusion, configurational theory is a useful way to look at how causes and effects work together. By looking at the different ways that causes can work together, we can gain new ideas and a deeper understanding of complicated things. Class, that's all for today. Remember to look over what we talked about and get ready for our next meeting. Enjoy your day.